So welcome. This is 9.2, which is page 82. This is our second set of transformations. So our transformations can be a translation, a reflection, or a rotation. Today we're going to talk about reflections. A reflection is a flip over a line called the line of reflection. Each point and its image are the same distance from the line of reflection. A reflection is also an example of a rigid motion, which is an isometry we talked about, which just means that it will be congruent. A rigid motion, which is an isometry, which means it will be a congruent shape. Common lines of reflection are your x-axis and your y-axis. Vertical or horizontal lines in the form of x equals a number or y equals a number. So that could be a line that they would ask you to reflect over. Or sometimes your diagonals, so something like y equals x or y equals negative x. We'll talk about some of these. Some of these are a little bit tricky, but we'll talk about them as we go. Okay, so the first thing I want you to do, I'm going to pause because it's boring to watch me plot. Go ahead and pause and plot the first triangle here. I'm going to go ahead and plot this one as well while I'm paused. Okay, so pause and plot those for you guys. All right, here is our image, our pre-image, and we want to create our image after we reflect it over the x-axis. So the x-axis, remember, y is the up and down, x is horizontal. I'm going to reflect it over here. Really all I have to do is I count to the line and I count to the other side. Here's my C prime. Count to the line, 1, 2, 3, 4, 5, 6, 7. Count 1, 2, 3, 4, 5, 6, 7. Here's my V prime. 1, 2, 1, 2. Here's my A prime. So my new shape, all I had to do is count to the line, count away from the line the same amount of units. This is a really tiny pen. Different ribbon. So here we go. And then you can figure out what the points are for each of those. A is at -4, -2. C prime is at 5, -1. Look at what's happening. This was at -4, -2. So the x stayed the same, the y changed by exactly the opposite. The C, the x stayed the same, the y became opposite. So B, the x is going to stay the same, it's still going to be 4. It's going to go down 7 this time. So it's neat when you recognize patterns like that that work. So over here, I'm going to reflect across the y-axis, 1, 1, 1, 2, 1, 2. Now this one is right on the end, so I'm going to go all the way to the end. This one is one away from the end. Here we go. I'm going to connect those points once I reflect it over that y-axis. You can count it, you can recognize patterns. It's really kind of up to you how you see that. Now, remember, this was Q prime, this was R prime, this was S prime, and this is P prime. So if I want to say where they are, that P was 1, 2, now it's -1, 2. Opposite x, same y. Q was 2, 5, now it's -2, 5. R prime was 8, positive 3. Now it's negative 8, positive 3. And then S was positive 7, 0. Now it's negative 7, 0. So it's nice when you can recognize or see some of those patterns. Sorry if I'm out of the way a little bit. Because if you can recognize and see some of those patterns. Anyway, we are going to go to the next page. I'm going to pause for a minute. Those are the only two we're doing on this side. Before we flip over, I did kind of want to point this out, that the rules, if every single time it's reflecting over the x-axis, your x stays the same, the y becomes opposite. So you can remember that rule and you can notate it. Every time you reflect over the y-axis, the x becomes opposite and the y stays the same. So these rules will be consistent every time if you're reflecting over the axes. Okay, I'm going to go to the second page where we're going to have other lines that we reflect over. We are going to do 5, 7, and 9. So if you want to take a minute and plot those shapes for 5, 7, and 9 first, go ahead and do that. So I took a moment and I drew all of those, and then I want to reflect it over the line x equals 4. X equals 4 here, so you draw the vertical line. And if I'm reflecting over this line, again, I count to the line, away from the line. This is my K prime, which is at 1, 2, 3, 4, 5, 6, up 1, 2, 3. So K prime is at 6, 3. L is going to be 1. L is at 5, negative 2. And then J will be 1, 2, 3, 1, 2, 3. 3, 5, 6, 7, down 1. And there we go. This is our new triangle at this location. There we go. So K prime, J prime, L prime, the new image. Can you do this one? So I plotted the original, and now I want to reflect it over the line y equals 2. Well, y equals 2 here, so that entire line is what we're reflecting over. Up 1, up 1. Up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 1, 2. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Again, use your straight edge if you want to be super straight. Oh, and mine's a little bit crooked. So, then go ahead and pick the points. Plot the points. Tell me what they are. C is negative 4, 8. Now, the one on the other side, because it was the x or the y axes, the rules made sense. And you could tell me what the points were going to be. When it is not the axes, not the x or the y axis, and it's just some random other line, you are not going to have a rule that you can just add or subtract from the same number. So keep that in mind. It's not going to be the same if it's not the axes. These other ones are going to be E will be 6, 3. D prime will be negative 2, 4. F prime will be 4, 7. There we go. So the thing that did stay the same here, actually, all of the x's did stay the same, the y's changed. Up here, all of the y's stayed the same and the x's changed. But there's not like a consistent number that the x's would change, so keep that in mind. This one, y equals x, is tricky. Y equals x is where, like, if y equals 1, x equals 1. If y equals 5, x equals 5. If y equals 10, x equals 10. So it's going to be this diagonal line if you have a y equals x. Counting to the line becomes tricky. Now, I don't care if you go horizontally or vertically to the line, you do the opposite away from the line. So let's say you go 2 horizontally, you're then going to go 2 vertically to get your z prime. If you go vertically, 1, 2, 3, 4, 5, 6, 7, you're going to go away, 1, 2, 3, 4, 5, 6, 7. If you go 1, 2, 3, you're going to go away, 1, 2, 3. So whichever direction you go to it, horizontal or vertical, you go the opposite away from it. Now, one thing that's really nice about this is the numbers that you get. Go ahead and write down what x and y, x prime, y prime, and z prime are, and see if you recognize anything. So x here is at 1, negative 1, or z is 1, negative 1. Y is at 1, 2, 3, 1, 2, 3, 4, down 1, 2, 3. So y is at positive 4, negative 3. What are you noticing? They're just swapping spots. So x prime is probably going to be negative 2, negative 5. Flip them. Negative 1, 2, down 1, 2, 3, 4, 5. And that worked. So that one's actually kind of, that's a nice one to do. That is it. You're reflecting over the line. Another way you can do some of these, I don't know what I'm going to do. Oh, I have this stuff called patty paper, which is basically like a tracing paper, and it's nice because you can see if this is the shape that I'm tracing or going to reflect over this line. So I usually have like an origin that I'm going from on the line. Let's say we're reflecting over here. And you can see through the paper, oh, I can't see my paper. You can see through the paper that it landed. So I started over here, copied it, traced it, and if I reflect over this line, I can see exactly where I end up. I could do the same thing down here. Let's say that I am going to reflect over this line. I'm going to pick up this paper and reflect over it, and notice that it lands in the exact same shape. So if you're ever not sure, you can always use patty paper. You probably have some of this in your baking section at your house, like with foil. You might have some patty paper. I tear it up and I use it to trace these. Anyway, that is it for the notes. Have a fabulous day, and I will see you next time.